Hi everybody.
I will present to you in this visual abstract a brief idea about our work entitled 3D crack identification using the Nelder-Mead Simplex algorithm combined with the random generation of crack positions. So, the process of identifying an internal crack in an industrial structure in order to make a decision about its structural integrity, is an issue that's still facing engineers. Used experimental methods have their specific advantages and limitations, depending on the application and the setup of the measurement system employed. Solving an inverse problem, by processing experimental data through numerical simulations, allow to complete the information needed to analyze a crack structure. The methodology is as following. Define the numerical method for solving the direct problem, the dual boundary element method in our study. Define the regularized functional to be minimized, it's our objective function. Define the injected parameters for the crack. Generate a random sample of crack identities to cover uniformly the whole domain and hold the one with the lowest value of the objective function. Use the selected identity to launch the minimizing procedure. Assess the stability of the algorithm to measurement noise. The first treated example is about the identification of an elliptical crack in a cylindrical shaft under uniaxial traction. Convergence is carried out after 1200 iterations, with an error fixed to 10⁻⁻⁵, but, after the first 600 iterations, error was less than 10⁻⁻⁴. To assess the stability of the method regarding measurement noise, a Gaussian law is used to generate a fixed standard deviation noise level, which is added to inputs as perturbations, and the deviations for the solutions are compared to the noise level. The second treated example is about the identification of an elliptical crack in a spur gear tooth. In this example, the optimal random crack's identity is obtained with a sequence of 50 iterations. Convergence to the actual identity is reached after 1200 simplex iterations, with a normalized objective function less than 10⁻⁻⁵. In conclusion, elliptical cracks can be identified by coupling a low discrepancy sequence and the Nelder-Mead Simplex algorithm, and using dual boundary element method for solving the direct problem. The crack identities generated by the LDS offer the NMSA its best starting solution to avoid convergence to local minima. The method is stable to measurement noise even if the number of iterations to convergence is relatively high. Thank you.